Good morning, everyone. My name is Chase Drum. I'm the West Coast correspondent for Autoline and also the host of the Grid Connections podcast. I have the pleasure today of speaking with some of the leaders in the automotive industry, and we're going to be recapping what Tesla announced yesterday. We'll go through a kind of quick overview of what was announced just in case you didn't see it, and then we'll be talking to the experts to get their opinions. So today I'm joined by Bob Galyen. He's the founder of Galyen Energy. Thanks for joining us today, Bob.
Thank you very much, Chase. Looking forward to it.
Great. And then we also have Sandy Munro of Munro and Associates. Thank you for joining us as well.
Thank you. Thank you for the honor. Thank you.
My pleasure. I mean, it's honestly, I've always been a big fan of both of what you guys have done. So it's really a big honor for me to join you on the West Coast this morning and be talking with both of you today. And then we also have, of course, John McElroy of Autoline.
I think he's in the blue room or something for a while. Yeah.
All right. Yeah. Well, he'll be joining us eventually. But just to recap, I wanted to share, we've had some viewers submit questions, so we'll have a kind of a Q&A following up on some of those questions a little bit later. But for those who didn't see, a lot of the technology that was presented today, or I'm sorry, yesterday by Tesla, really is kind of, in my opinion, a pretty big difference from what we've seen. I would love to hear Bob's take on it and Sandy's both. But to me, I think what I at least saw when Tesla and a lot of these other auto manufacturers went from the 1865 to now the 2170 spec, that seemed more like an evolutionary use of what was essentially laptop batteries. And now with this announcement yesterday from Tesla, it does seem to be, in my opinion, kind of the first real automotive grade cylindrical cell. So we have a few quick slides that we can kind of bring up to show what was announced yesterday, and we'll go through those real quickly for anyone who might be watching right now that hasn't seen it already. And then from there, we'll start talking with Bob and Sandy to get kind of what their takes on it are and what this could mean for the greater automotive industry. And feel free to submit questions in the chat while this is going on as well. So let's, with that, can we bring up the first slide? So what was announced yesterday kind of looks like almost a Red Bull can compared to the more traditional cylindrical cell size that people have seen when it comes to the batteries overall. It's a much wider and a slightly higher cell, or the can for the actual cell itself. And as we kind of, let's see, go to just the next slide after that real quickly. It really does highlight some of the advances that had been more or less leaked in the media about what might be announced today, specifically their technology around a tabless cell that they had patented. And this really does give some advantages around essentially being able to keep the battery itself a lot cooler by the electrons being able to essentially leave the cell in a much more efficient manner. And Bob or Sandy, I would love to kind of get your take on this. If this is, it was the first time I've kind of seen this used in this way, but I'd be curious to see if this is something that you may have seen in another industry, or just this is the first time it's used or more publicly known.
It's the first time we've seen it, that's for sure. The tabless idea is a great one. And that's not one of the things that I predicted. I did predict the size differential and things like that, but I did not know about the tabless battery pack. How about you, Bob? Did you ever see that before?
Oh, it's been something that's been contemplated in other battery designs, not just the lithium-ion battery, but when I look at overall battery technologies, a lot of these kind of things were way back in the 1920s and 30s. If you go back and look at the patent literature, but one thing that Elon and his team did not mention yesterday was this tabless configuration also helps with heat transfer. If you look at the aluminum and the copper and the way they can put the can together, it really does help with the heat transfer characteristics of the cell. So in a way, it's a very good design. But is it new? No, it's been around for a long time, but it's being applied in a different way in a different electrochemistry.
Yeah.
Hey, you
looked at
guys,
the,
I've joined. I had some computer problems, but I'm there. Bob, Sandy, great to see you guys. Chase, you as well.
Good to see you, John.
Morning. Yeah. Glad the computer issues have disappeared.
Oh, no, they haven't.
Oh, really? Is that why you're sitting there?
You can see and hear me, but this is not the way it should be.
Oh,
But forget that. So I didn't mean to interrupt, Chase. Continue.
Yeah, no worries. Great to have you, John. Glad everything got worked out at least. But yeah, it sounded like you were about to say something, Sandy.
We've been, we've in the past we've said that the battery pack that we like the best is the Tesla pack. I mean, it's been that way for quite some time. The only thing we didn't care for was the manufacturing technique with having to use those extrusions with the micro channels and whatnot, and trying to cool from the sides. When in actuality, heat is axial; it goes up and down the middle. And so we were wondering why they didn't cool from the bottom. Or anyway, this thing basically makes it all happen. And by the way, we kind of are making a battery pack. We started it, but when we saw what happened last night, it was beyond our wildest expectations. So we're changing it around. And this is kind of just an illustration for those folks who don't know what the size differential is. This one is a little bit shorter and a little bit bigger in diameter than what was shown last night, but this is out of the Y right here. So you can see there's a big difference. And when you start packaging them, and we put that on the cooling plate, this is much better for sucking the energy, or the heat, I should say, out of the battery, which keeps the energy high, keeps the life expectancy for the battery high. Everything is better when it's bigger. I think that's the right way to go. So what do you think there, Bob?
Well, certainly the bigger the active materials are that you can package, the better off you are, because you get better energy density that way. That's one of the reasons that my old alma mater, CATL, decided to go with a prismatic configuration, because mathematically, the prismatic cell, you can put more energy into a given volume than you can with the cylindrical cell. But the Tesla team decided to go with the cylindrical for multiple other reasons in the way they designed and built their package. And when you look at the technologies that are out there today, Sandy knows from doing competitive analysis. He and I have done a lot of different kind of competitive analysis for years. That the different configurations, they all work. It's just the different philosophy that the design engineers have for utilizing available components and space that they have to package in.
Yeah. Well, the big thing for me is this is cheaper than that. Okay, so this is kind of one of the things that you might look at. I mean, they come in different configurations and size, but these are all basically prismatic. And then for those who don't know, this is kind of like what they use as a plastonic pouch style. So, live. Well, let's put that right back. Anyway, so I think that for me, the amount of energy I get out is great. But what I like even better is, how am I going to manufacture this? I can crank these out like there's no tomorrow. These come out by the thousands per minute or something. Whereas this one is that's a little tougher to manufacture, and so consequently a little slower. But I think when you put these things together, like I say, which we didn't have it done yet, but when we put it all together and whatnot, and based on what they're saying, they're going to take this and then basically epoxy it into the cooling plate and whatnot. I mean, I couldn't be happier. For years, I've been saying you can have reliability or serviceability, pick one. You can't have both. And this basically glued to the cooling plates and then gluing to its brothers and sisters. This is for me, the best. I was really excited when I got done. So I don't know. I think that at the end of the day, this is going to kick some serious. This is better than they've got right now. Like I said, I like the battery, but I didn't like the cooling system. I love this cooling system, and I love the diameter. I love the energy pack. So.
Yeah, I think what was pretty interesting was I have a few friends who were hoping that, I mean, they did kind of announce their new fully bells and whistles Model S, or at least announce they'll be coming out next year. But most of, I think, people who are in the automotive industry were just like, oh, this is kind of boring or kind of a letdown. But I personally found it super fascinating with the strategy they're taking. And I think Bob's point about the thermal effectiveness of it is going to be huge for them. And there's one slide that they kind of showed where it just looks at the charging, like the thermal properties around supercharging. And I think there's a lot that they're going to be able to do with this style that they just, that I think others can have tried to go the way of higher voltage. And this will be kind of a way to kind of get around a lot of those things just inherently with the battery design. I would love to hear kind of your thoughts on that, Bob, or if there was anything else around the thermal side of it you wanted to mention.
Well, I sort of like to go back and look at history. John knows I think he was actually at SAE when I gave the paper probably 5-6 years ago on the history of electrification. And I look at this battery announcement yesterday sort of on the equivalent of what General Motors did back in the 1960s and 70s when they announced their Freedom battery, where they went from a different alloy in the battery so that it could be maintenance free. So you no longer had to water the battery because everybody either overfilled it or underfilled it or didn't know what they were doing and created a problem. So I sort of look at what Elon and his team have done is they compiled a whole bunch of potential improvements that they still have to work on and verify that they will indeed work. And kind of equated that to what we did in the lead acid industry over the last few decades of development of that batteries. As I've seen in the past, I think the next generation of battery will be advanced lithium. It was interesting that Elon's team did not mention solid state batteries, because I think he agrees with some of my buddies at our national laboratories that we will continue to see lithium-ion batteries as the mainstay in the industry for at least a couple more decades. Lithium-ion is it's becoming more cost-effective, and all the benefits that we have from lithium is being manifested with new manufacturing technologies. If you look very carefully, the modifications that they're making in chemistry is no different than what other battery manufacturers are aspiring to do as well. Every one of these large battery manufacturers have large research institutes that are developing their own chemistry. It's just they don't talk about it. Elon chooses to talk about it because it helps him with his normal persona of showing everybody what he's doing, so that it helps him with these market shares, which is perfectly fine. So I don't think anybody's going to beat Elon up for what he's done to help the electrification effort, because certainly those are the kind of things that, like, Sandy and myself have aspired to do in our whole career. So I think it's a good thing that he comes out with these kind of announcements. Now, the amount of work that goes into each one of those new developments that he's talking about is massive. And I don't think there's anybody in his organization that would dispute that, because it is a major undertaking almost in every turn that he mentioned during his talk yesterday.
Yeah, I think you bring up two great points. Oh, what were you going to say there, Sandy?
Well, he said something yesterday that really drove home the point. Anybody can make a prototype. Manufacturing is hard. He said it like 3, 4, 5 times. That's the real key. I can make anything work once. I don't know how long it's going to work and whatnot, but I can point at it. And we've seen lots of people come in here with here's a piece of plastic, and look, it's a battery, and they cut it up in little pieces with scissors. Okay, fine. How can you make 3 of them? No, that's our only one, and we cut it up for you. But actually, at the end of the day, that's not manufacturing. This is manufactured. This is something that He's got prototypes working, and he's scaling up. He's got that little plant next to Fremont cranking out these things. I was blown away. I think that for me, maybe Wall Street didn't like it, but Wall Street's, I mean, really and truly, they've got a lot of people there that are analysts and things like that, and they look at stuff in an entirely different way. For me, last night, if I was a CEO of a big OEM, I'd be wetting my shorts right now, because this is a turning point. 50% lost cost, 59% more energy and whatnot. This is ridiculous. And not only that, it weighs less. Now, all of a sudden, I mean, I can see a $25,000 car that's worth basically driving with this thing. With this, it's too heavy. I mean, it's too heavy. This is perfect. This is like I said, this is the end of the ice age. I've said that a couple of times, but this battery is. I don't need to have the solid state battery anymore. I got this thing. I'll take that all day long. Like 50% weight loss, I'll take that all day long.
Yeah, I think that's a great point around the solid state. I think a lot of people were expecting that, but with the numbers that they're able to deliver, you really don't even need it. You're getting what you need with this current product. And if they're able to do something around solid state down the road, great. But 56% price difference, like you said, Sandy, the range, incredibly impressive either way to get to those. I mean, they were kind of saying that the first line will be live in about a year, and then within 3 years, it should be at a pretty much full production. Can we go to, I think it was the third slide we had prepared, where it kind of breaks down where they're looking at these different numbers to get to this 56%. This was kind of from it yesterday, and between the cell manufacturing, the factory, some of the stuff that they're accomplishing with the car design, I think this really does highlight some of the value of a vertical integration that Tesla has pursued. It seems like, I think, for a long time that people were kind of wary of it and they were trying to take on too much. But between the price reduction and also with this new cell design, like both you, Bob, and Sandy have said, it does seem like it's unlocking a lot of the things within a very quick timeline, that a lot of these things that have kind of been prototypes or R&D or like, oh, it's 10 years away. It's just not feasible to really even be looking at those anymore.
Well, Chase, you brought up an interesting point. And the last time I was on the show with John, I showed this wonderful slide that Dr. John Warner, who's an author of 2 different books in the lithium world, had written. One was specific to battery packs, the other was to battery chemistry. But Dr. John Warner put the 2 slides together. One was the adoption rate of lithium-ion battery. It took 42 years from the time we discovered lithium-ion battery on the benchtop till we had 500,000 electric vehicles on the road with lithium-ion batteries in them. That's a long adoption cycle. The rate of accelerated technology today has been manifested by the use of computers and modeling. I know, again, I mentioned my old alma mater, CATL, went from 0 revenue to the biggest battery manufacturer in the world in 5 years. Can miracles happen? Absolutely.
Okay, so I'm gonna expand on that. This is the presentation that I gave in what do you call it, in Asia, like OTA, over the air, like what we're doing right now. And if you look at the bottom, there's my title. We're entering the age of acceleration. I mean, I've given it 3 times. The only thing I changed was era to age or something. Oh, do you want to? All right, fine. But at the end of the day, it's for the people who actually understand the engineering behind things, EV stuff. This is big stuff. This is big deal for the people on Wall Street who are listening to analysts that are, I don't know, MBA trained or something. I don't know where their training came from, but I'm telling you what, I couldn't believe it when I saw that the stock went down. That thing should be skyrocketing. That should be to the moon. Are you kidding? What you just heard was the gospel of according to EV. I mean, You
I
can't believe how excited we are here at Munro.
Sandy,
we're all
you bring
dancing.
you bring up a great point. So I think looking at a lot of people have been trying to figure out Tesla's valuation, all this stuff. They've been looking at them for a long time as a car manufacturer. I think a lot of what they've done this past year, and especially yesterday's announcement, was really them kind of transferring to more of a Apple-esque. They do hardware, they do software, they have that vertical integration. And I think what you see with a lot of, I think a lot of companies in general, but especially around the tech companies, is you have the buy on rumor, sell on fact. And so I think the stock market had been growing for weeks, and then finally the truth came out. And maybe some people were disappointed there weren't more products, but as far as the actual technology, the path and everything, I completely agree with you. It was very impressive. I think real quick, let's go to, I think it's slide 4. If we could just pull that up real quick, that goes into kind of a little, yeah, here we go. Perfect. I mean, these numbers are, even if, I mean, I was kind of thinking when I saw like just even 54% range increase, if they were able to just do that number, that would be impressive. If they're able to do all of these combined, that truly is, I think, like you're saying, Sandy, a serious game changer. There's a few bullet points just I want to go over.
Well, before you leave that slide, you don't need to put my picture up, but before you leave that slide is everything that says, if you're investing in ICE vehicles, you're screwed, because that is the key slide for everything. All the rest of the stuff, it doesn't matter. That one right there, that's what happens when you have vertical integration. And I know I've heard lots of Harvard guys tell me I'm full of shit, but I'm telling you flat, this is what happens when you have an R&D center that gets a lot of money and gets a free rein on, hey, let's be the best on the planet. And that's what happens. And the boneheads that are saying, oh yeah, we're going to sell short, those clowns, I have no idea. They're not engineers. I don't know who they are, but they're not engineers. And I'm telling you, that slide should have been the wake-up call for everybody to say it's time to get. And by the way, my prediction, 2030, that's the end. That's when it's going to flip. And that'll mean that other car companies are getting in. But that slide is the key slide for the whole future. That's it right there.
Yeah, and I think it goes to Bob's point really well about with this current status, lithium ion will be around for quite a while with these kinds of numbers and ability to deliver. If some of the solid state technology that's kind of being in the labs right now goes farther, awesome. But those numbers pretty much make it kind of hard not to make that transition.
Yeah, I'd like to ask Bob, but what's your sense? I mean, you were at CATL. Is Tesla really that much farther ahead than, say, where CATL is in terms of price reduction and the like? General Motors says it's going to get under $100 per kilowatt hour at the pack size in a couple of years. I just like to get your sense. Is Tesla really that much farther ahead than everyone else?
No. I have to be a little careful, John. Part of my agreement with Robin when I left China was I wouldn't talk about CATL. But, you can go and look at the literature. Approximately 2 months ago, they started the new 21C laboratory. It's interesting that 2 of the Nobel laureates sent letters to Robin and congratulated him on the starting of this new 21C lab. A guy that wants to protect his investors, don't go out and tell the world exactly what they're working on. Just like the big car companies, the GMs, the BMWs, the Audis, the Fords, the Chryslers, the Fiats, they're not going to go out and broadcast what they're doing because their competition is going to know what they're doing. Tesla takes a different approach. They tell everybody everything. And a lot of the things that Elon mentioned are very forward-looking. If you look very closely, and I'm not trying to dampen Sandy's enthusiasm because I'm probably the biggest cheerleader in the industry for electrification, but I'm also a realist in helping grow CATL to where they're at today. It took a heck of a lot of work and a lot of diligence, the hours of labor and knowledge that was put into it. I just got through putting together a slide deck that shows the convergence of the cognitive skills and the knowledge base that is required for someone to take technology and turn it into cash. John, you've heard me say that a few times. Technology into cash is the key, and this is what Elon and his team are trying to do. They're just more vocal about it than the other companies. So is there a differentiator between technology that other companies are working on and Tesla? No, those guys are working on similar types of technology. In fact, since I've semi-retired from CATL, I have contracts with other technology companies that are working on things that are beyond what Elon and his team are talking about. So they live in their own development world, and that's fine. Just like any other large corporation, whether it's Magna Corporation that makes components, or whether it's a car company like GM that makes the automobile, all these people are aspiring to make money. And the way you make money is to take technology and turn it into cash.
Well, I'll tell you, the thing that I look at is basically sitting in back of me right here. Did Tesla tell anybody that they were going to go to a casting that size? Nope. I don't think many people saw it until I ripped apart the Model Y. And now this is obsolete. This is obsolete. This is only half of the size. The real size is double. And I said that I have no idea why they're not doing the front of the car as well. You probably can't see it because it's off the screen, but now they showed last night that not only they're going to do the rear, they're doing the front, and their battery pack is basically using the same kind of technique and technology. They didn't say anything about that. I think what Tesla does is, yeah, they warn their competition about what they're working on right now or what they think they've got in hand, but I have no clue what they've got sitting in reserve. I think that Tesla likes to tease. I mean, sitting in front of me is the octo valve. Who's got that? Lots of people had what do you call them? Heat pumps. But these guys, they went and made that. Okay, thanks. Anyway, this is the octo valve. But they took what everybody else had and turned it into magic overnight. I mean, I can't begin to tell. I have no idea what kind of a budget they got for R&D, for vertical integration and making things better. But I don't know. I know for sure we didn't have anything like that at Ford when I was working there. Never. We did lots of R&D, but nothing compared to this. I mean, battery technology, heating and cooling technology, aluminum castings they've got their own blend of aluminum in. I mean, on and on and on. Even we're not there yet, but when we talk about the ADAS board, see that chip in the center? We don't know how to make that thing. We can take every chip and take it to pieces, but that thing's scary. When you look at it from the other side, I mean, look at the number of joints. It's like impossible. This is impossible. How does it do that? So this thing is costing us a fortune trying to reverse engineer that chip. It's gigantic and it's revolutionary. What do you call it? Not what's the name of the other chip manufacturer? NVIDIA. And this is a better chip than NVIDIA. NVIDIA's been doing this forever. That's their job. And yet Tesla comes up and says, "Oh well, thanks. We're not going to buy your chip anymore. We're going to make our own." So that's kind of that's. I just think they're not a car company. They're like Edison's lab or something. It's totally different for me.
I think this does highlight kind of two good points. I think what Bob you're saying is kind of as far as the actual battery technology, it does highlight. Even they said it yesterday. They will continue to work with CATL, Panasonic, LG, and their existing battery manufacturing line, and a lot of their patents are open anyway. So they have that access, and they also have the ability to kind of go back and forth with sharing. I mean, and some of the stuff they did share wasn't just something they discovered; it was stuff that they have been working on in partnership, and that is a good point to look at. And I think where Sandy kind of brings in is also not only are they working closely with the battery manufacturers, but it is also designing it to be in a way from how their car is made, especially around the castings and a lot of kind of weight savings along with kind of safety that you can build into that. They wouldn't be the only one, but it definitely does seem to be they are the one doing it. Thinking about it to the furthest, at least from what I've seen. I've heard some like of the Chinese automakers are really starting to get pretty like looking for similar optimizations they can make with their cars. And I'm sure Ford and GM and everyone else is talking about it. But I think there is also the pro and con of being so open with this is the fact that they can kind of show what the table stakes are, and it does help to get that buy-in from the people who are on kind of the Tesla train already. I think it does Tesla does a really interesting job of kind of bringing all these three areas together. The openness of what they're working on, working with existing supply chain and battery manufacturers, and then also kind of taking the Apple approach to really just look at ways they can streamline all these technologies together. I realize we're already about 35 minutes in. I wanted to answer get some of the questions that have been asked, but I think one thing I do want to, before we get into that, one thing I really want to cover was the fact that the cathode has no cobalt. It's clearly something that was going to happen either way, but it definitely does kind of remove. I think there's been a lot of naysayers that look at cobalt as the big kind of bad truth that's going to not create the environmental impact that people have been talking about. But now that the cathode, and once again, like you said, Bob, they're not the only one doing that, but they're definitely being the most open about how they're getting to that, I think, in a lot of ways. And also, they're not dependent on one chemistry. I think I was surprised they didn't mention more about some of the work they've done with CATL around iron phosphate. But I was also impressed how they had kind of a slide that showed how they're looking at kind of the nickel-rich batteries be for the Semi and the Cybertruck, the things that are, as they put, mass sensitive, which I thought was a cute way to say just really friggin' heavy. But on the other side, you had the things that were kind of like what's kind of being designated their Model 2, which would be more of the iron phosphate and stuff that's more cost sensitive. And I think a lot of, especially to what Sandy was saying, a lot of these kind of Wall Street or other kind of tabletop, I forget what the expression is, but essentially people who are kind of looking from the sidelines, they assume that Tesla, or most of these car companies in general, but Tesla especially, seems to be invested in only one chemistry. And having kind of a strategy of how to put these resources so they could get to their level of scaling, plus having the right resource and supply chain enabled to really execute on how many cars they want to produce, I think really does show some pretty interesting thinking that I don't think people fully appreciated.
Well, Chase, you hit on a sweet spot that tickles me a little bit, and that is, during the presentation, Elon also talked about his energy storage business as well. If you look at the volumes of batteries that are going to be required, there's no way in the world that Tesla could ever make enough batteries.
Yeah.
Or their car alone.
I was surprised they didn't talk about energy storage more, but yeah, continue.
So that's an area that I've been working on aggressively since semi-retiring, because that is a part of the strategy of all the battery manufacturers, is to try to make the world a greener place. And the amount of batteries that are going to be required, I think Elon mentioned that it's going to be something like 1,600 times growth in the energy storage market alone. But he also, during his speech, he made several off-the-cuff remarks, and I'm gonna quote Elon on this. He said, "A lot of work to do. We have major issues. We're close to working, but we don't have good yield. Okay, a ton of work to be done. Will be on the main machine 6 or 7 version by production." And they were on, I think, generation 3 or something like that when they were giving their speech. So Elon even realizes that the speeches that they make, they've got a tremendous amount of development work to do, both in technology and in manufacturability. And during the last time I was on the show with John, I made this comment multiple times and even showed slides about how you scale manufacturing. It is not easy. There's lots of mom and pop shops out there today that can make a great battery on the benchtop, but trying to take that thing commercial and make it in the mass volumes that the large battery manufacturers are making today is not easy. Scale means everything in battery technology. Even in some of the comments that were made about how to take the raw materials from the mine or from the soil and turn it into useful products, there's a tremendous amount of development work that still has to be done in that area, whether it's a lithium or a nickel or the manganese or whatever component it is that's going into the battery, still requires a certain amount of processing that has to be developed. So,
that's very interesting what you're saying, Bob, because look, I was blown away by the presentation last night. I thought it was terrifically done, but I've never heard Elon add so many qualifiers in any presentation that he's done before. As you said, there's a long way to go, a lot of work to be done, low yield, this and that and the other thing, 3 years away, blah, blah, blah. I'm almost wondering if it's because Trevor Milton just got nailed for exaggerating things and maybe even misleading people, that Elon has decided, yeah, we're going to put out all this that we're doing, but I'm not going to be as exuberant maybe as I have been in the past.
That is actually a great point. But if you look, I think if you look to their autonomy day that they did last year and what they it's a roadmap meeting. It's not a product announcement. I think you bring up some valid points, especially with I believe the new Roadster and the Semi were announced in 2017. And they're supposed to come out 2020, and now
even more, Chase. Look, full self-driving was supposed to, full autonomy. It was supposed to be available right now, and it's not there. Look, I believe they are going to get there. That's one reason why I think Elon's been given the benefit of the doubt. Even though he's overpromised and underdelivered, ultimately he does deliver.
Good point.
And that's why the stock market has loved what he has said. And maybe they're a little bit miffed that the announcement last night wasn't even more grandiose. But I actually found Elon to be more believable when he's saying, hey, look, we got a lot of work to do on this.
Well, I think that one thing that he said last night, or there was, if you listen to the stockholders, the shareholders report and whatnot, there were a few people that came up there and said, hey, we should have unions, and hey, you've got civil rights issues and things like that in your factory and whatnot. I know that there's gigantic funds that are focusing on those kinds of issues, and I think that may be one of the reasons there was a big sell-off, because they basically dismissed it quickly. How many people vote? Nope. Okay, well, that's dead. And the only one that I really was taking note of was getting rid of the use of cobalt, which can only come from really one place, which is the Congo, and that place is a real hellhole. So I think that might also be a combination where the people who are in charge of those funds just said, hey, if he's not going to do that, yank it, and they did. That's one of the things that happens when you're running a publicly traded company. But as far as what he did say, and the focus that he says, I'm going to get rid of cobalt, and I'm going to mine lithium right here in the United States. Those were key elements for me. Especially, I'm positive that there was people in the DoD that sat up and took notice of that one, because there's a lot of people in the DoD that are worried about where are we going to get some of these raw materials. And now what we're looking at is a guy who's going to go from raw materials to product. That hasn't happened for a long time, not since Henry Ford. So there's a lot of good things that happened, but there are some things that he said that probably irritated some of the shareholders, and they just said screw it, and they backed out.
Chase, what else you got on your list of things to cover?
Well, I think I just, one thing to mention, I think you kind of brought up how Elon was prefacing a lot of stuff, and I think that is true. And I think maybe they're just kind of getting a little more mature and realize their Model 3 ramp and everything was such the public hubris of the challenges they faced. They're maybe more realistic publicly. I don't know. But I think what you called out there is a good point. And I think what is also really interesting is just the fact I've never seen an automotive or even like Apple and maybe a couple tech companies will just dip their toes into like supply chain and the manufacturing of when they make the new iPhone or whatever product. I was surprised at how big of a component, how they kind of push that publicly. And once again, to Bob's point, a lot of people do this. It was just kind of interesting to see that side of it. And then a big part of it being a lot of it that they're planning will be done domestically. And I think some of that could be nationally security driven. I think a lot of it's cost driven. Just so, as he was kind of even saying, they were shipping these things cost and also environmentally driven. Sometimes they ship these things back and forth all over the world a few times. And the more you can do it regionally, the better environmental, the better cost efficiencies. And to be honest with you, I still think we've only scratched the surface of a lot of the content that was covered yesterday. I watched it probably 2 or 3 times just taking notes. But given that we're kind of coming up on the time, I'm just going to, there's a few
questions. We can go longer if we have to. We don't have to hard stop in an hour.
Well, sure. Chase, let me make a comment. You know, as a scientist industrialist that I've become over the 43-year career that I've been privileged to have, I look at what they did yesterday is incremental improvements. What I see is Elon and his team are doing a very good job of basically taking a complex situation, breaking it down into its fundamentals. Just like Coach John Wooden, when he was a UCLA coach, he always started the boys off with shooting layups and free throws. Coach, why do we need to do that? We know how to shoot layups and we know how to do free throws. If you do it as a habit, when the rush comes, you're going to be able to do it and do it automatically because you've trained the mind and the muscle to do it together. But as a scientist and an industrialist, I look at what he has done is just incremental improvements through good science and good technology. It's going to take him some time, and he openly admitted it during yesterday's event that it's going to take some additional work to get things done. Dr. Robin Zung in the CATL didn't build CATL overnight. He had a great team behind him. They did great work. The same thing with all the other major corporations. And Sandy brought up Henry Ford. You know, if you want to compare what Elon is doing to what Henry Ford did back in the beginning of the industrial revolution, if you will, the second industrial revolution, building larger, massive amounts of cars, they're doing nothing but announcing the things that they're planning on working on. And they're already in progress in some of it, and they will be successful in some areas, and they won't be in others. If he hit 100% of everything he talked about yesterday, it's going to take him a few years to get there, by the way. If he does that, by that time, do you think these other companies like a CATL, a Panasonic, an LG, a Samsung, BMW, General Motors, and all these other large corporations, do you think they're sitting idly by? No, they're going to be giving him some competition along the way. So as an industrialist and a scientist, I look at what was mentioned yesterday as normal course of work. This is what you've got to do to stay in business.
The thing that I look at with Tesla is speed. How fast did they do everything? So John knows that, excuse me, John knows that he came over here in 2018, early 2018, and we looked at a pile of crap. That Model 3, I couldn't believe my eyes. And here we are in 2020, 2 years later, and I told him, I said on TV that 175 parts for a wheel inner, plus who knows, 200 or so spot welds and whatnot. And the next thing you know, you got that thing sitting in back of me 2 years later. I don't even know how you made the machine tool fast enough. I am a tool maker. That's what I did for a living until I got lazy and decided to become an engineer. But at the end of the day, I'll tell you, that die right in back of us, that's a killer. There's a lot of stuff going on there. And 2 years, here's the Model Y, bingo, here it is, problem solved. 170 parts down to 1, but now, remember, it's going on both sides. That's got to be more like 400 or 500 parts. All of a sudden are gone. How big's my stamping shop now? how big, how many welding guns do I need? How many robots do I need? I mean, he just chopped out with the front and the back. I don't know if I even need I don't even know if I need a body shop anymore. There should be a lot of guys in the stamping world that are going to go, I hope that everybody doesn't go in this direction. I don't even know how he got the press that makes this thing. I don't know how he got them done in 2 years either. It's just, I'm telling you, the guy, he's like Dr. Deming. Deming used to tell us all the time, just, tell what you're doing. It doesn't matter anyways. And when the Japanese were coming to basically kick our butts, and the Japanese told us what they were doing, and we didn't believe them, and we watched them gobble up the market share. I think Tesla's doing exactly the same thing. I think he reads what Dr. Deming had to say, and he implements it. Like I say, continuous design improvement. Who ever heard of that? I mean, and yet sitting in front of me and that thing right there, the octo valves had 13 design changes. 13 design changes since April until basically I think they were here in July, and showed us the new one and went, holy mackerel, I can't believe it. How do you make 13 design changes that quickly? It would take us a year at Ford to do that. So I think the big companies, as Bob said, acceleration, and as I put in my presentation, acceleration is what they've got. These guys move fast, and that's a tough job. I think I said one time, let's see how the elephants tap dance. Tesla can tap dance. I'm hoping that the rest of them can start figuring out how to do the same thing.
I'd really like to get your take and Bob's take on backwards compatibility. Going with what you're kind of talking about with the battery and the car changing so much, the chemistry changing to somewhat, and kind of how do you look? I know Tesla even mentioned they're going to start launching a recycling program. I believe CATL is already doing one internally. How do you look at backwards compatibility, and how, as this battery technology kind of keeps moving forward, what there is the opportunity for Tesla and other electric car manufacturers to address that? Or even, do you think that there's a strong possibility that third parties could just step in, and in 5 to 10 years, when you need to replace the battery pack, instead of going to Tesla, you go down to the Jiffy Lube and you get the new solid state pack put in?
Chase, I think you missed one point that Elon made yesterday. Most of the battery packs will outlive the car.
That's correct. That's what I was just going to say.
The life,
I was trying to work in one of the audience's questions,
yeah.
But that is a good point.
Yeah.
well, there, the existing today, there are battery technologies will last the lifetime of the car. It's a matter of proper integration and proper use of the technology that exists. So Elon's not saying that he's blowing smoke on this topic. They expect the battery to last the lifetime of the vehicle.
Yeah.
And it's achievable today with the right chemistry and the right integration.
I believe they'll outlast the vehicle. I don't think the bodies will stand the age. I think what you're going to wind up with is a battery that's still got value, maybe an electric motor or two, but the rest of the car is gone. So you're going to be recycling. The batteries so that you can make more batteries. And again, he brought that up. If I have to recycle, good, because what happens is I get my raw materials cheaper. And that's why we recycle pop cans and old airplanes and stuff like that, because it's cheaper to recycle than it is to go and mine new stuff, even if it is in a third world kind of country. It's cheaper
here's
to do
a
it that way.
counterintuitive question. If the battery pack's going to outlast the life of the car and then it has to be recycled, are the packs being over-designed? I mean, if you want to talk about sustainability, you should design something to last its natural life. Otherwise, you're just putting more energy into trying to use it. Or am I off on that?
Why recycle if you can reuse? I mean, once the battery is no good for a car, I can take that and pop it into a power supply. I mean, these things last a long, long time. I remember when they first came out, everybody said, oh, it'll only last 3 months and then you're going to buy a whole new battery. Bull. I never believed it then. I certainly don't believe it now.
Yeah,
I
but what I'm
think
getting
that
at, Sandy, is why should I, as a car buyer, pay for somebody else's power supply 15, 20 years down the road?
you won't. You'll get a money for it. Somebody's going to pay you for it. I'm going
I
to pull
think
the
they brought
battery out
up,
and put it someplace else.
yeah, I think Tesla brought up a good point yesterday, kind of going off of that cost, where someone asked them, when will they be cost competitive? And Drew, their VP of engineering, kind of said, in the markets that we compete in, we already are. We just are not in the kind of the $25,000, which is where they're going next. Yeah. So you're getting that value. And I think there's already, what I'm more impressed with is not the value of what you're paying for to get that, is what we're already seeing in secondary markets. You do a couple quick Google searches or YouTubes and you're seeing people pop these out, building their own power supplies and stuff. I don't know if that's always the right thing, but it's showing that even before you look at recycling, these things have a huge market to them already. And I think that's only going to grow. And yet, while they're still in the car, I mean, it's an electric vehicle. You have so few moving parts that maybe the cost becomes, instead of like kind of what Sandy was alluding to, maybe at 500,000 miles, you replace the seats or whatever you need to do to just kind of keep getting more life out of it. And that becomes kind of the family kind of junk car that you give to your son or something. Yeah, I just think as far as like the actual technology and the hardware of it, the battery component, and I think, Bob, you can probably speak to some of the great stuff that's being done in that field around the chemistry. Like you're looking at the 1,000,000-mile battery. I think Tesla was kind of pushing that narrative, obviously, around they need that for their semi trucks and also if they do the robo-taxi thing. But I mean, you're just seeing this across the board. It's not a Tesla only thing. It's kind of the science is pretty strong there.
Well, Chase, I go back to the 5 golden rules that Dr. Jonas Barisa and I put together years ago when I was still a Magna. Safety, performance, life, cost, and environmental. If you can follow those 5 golden rules as a discipline in your work, your electrification efforts will be successful. But in looking at what Elon was talking about yesterday, if you listen to some of the subtle comments, he was tying together the aerospace industry to the mobility sector and automotive specifically. You're opening doors for new technologies to be applied in other fields, such as heavy duty equipment and aerospace. There's over 100 aircraft corporations around the world today that are working on electric airplanes for what they call regional transportation. These are aircraft that will fly short distances, 500 kilometers, or with a passenger load of only 6 to 12 people, because regional airports are only under 5% utilized today, but they can carry a higher load of people coming through those airports. So I think you're going to see a transformation in the mobility sector based on a lot of the new technologies that Elon was talking about yesterday, but they didn't bring that up. I mean, these are and because I sit on SAE as the Battery Standards Steering Committee chair, I get to see a lot of these new technologies that are bubbling up and the things that are needed to support those. My disappointment is Tesla's not on a lot of our committees. I wish they were, because these would be very helpful to us and help propagate the electrification effort even faster. So I admire what the guys did yesterday, but for myself as a scientist and as an industrialist, I didn't see anything out of the ordinary yesterday that really turned me on, but it was addressing the shareholders and the general public that are not skilled, like those people that are probably listening in on the show today, because those people are listening in on the show today. This is what they do for a living. This is normal for them. It's only those guys that were honking their horns out in the parking lot that were getting all excited about Elon and his team telling this. But for most of the big car corporations and the battery manufacturers, this is the normal course of business.
Well, I'd like to actually build a little on what Bob was saying here. So Munro is also in charge of a NASA lab called Michigan SATS, Small Aircraft Transportation. And for me, one of the big things was 50% weight reduction. That was huge. So John knows because he's seen it. We developed an airplane, and one of the one of the versions so it had a gasoline engine, it had a diesel engine, and then we also wanted to have a battery pack so we could go with electric. And when we designed it, it was just bad timing, but it was in 2008 when we were supposed to go into production. It didn't work because the banks all melted. But in that proposal, we had to drop batteries because they were too heavy. The expense didn't matter, but they were too heavy. Now we're looking at two things happening. One, the cost has gone down significantly. When we did the analysis on the Model 3, the price was 150. What was the price? 150 something, 56, 156 bucks per kilowatt hour. Now it's 108. When Elon said that he had already matched it, I can tell you for sure that's the truth, because we did the costing on it, and we do very accurate costing. So they were at 108 when we did the Model Y. If we go to this thing, we go to the bigger, 4680. I think that we're going to see even a lower price, because I have to wind, I don't know, I'd have to at least do 6 of these things in order to get the density of this one. And and now this thing goes into a jelly roll, done, and out the door. These are much faster to build than the prismatic or the pouch. I think that the wave of the future is the electric aircraft and regional transportation, small aircraft transportation system. That was our focus. We were looking at something a little bit further, but actually, but at the end of the day, I could fly from Troy to someplace in grandma's house, someplace up north or what have you, and all of a sudden, it's convenient, it's easy, and it's inexpensive, and I don't have to get on the expressway to get there. There's a lot of advantages to that.
Yeah, I think that's
excited about that too.
That's a great point from both of you, because I mean, obviously, what most people were thinking when they think of the Battery Day announcement yesterday was automotive. Like you mentioned earlier, Bob, the grid storage potential is huge with what they're kind of working with. But at the end of the day, I think what they were looking at saying is, this is Battery Day. We're going to be putting it in cars. We're going to be putting in grid storage. But this is now getting to the point with our partners at LG, Panasonic, that this is kind of a turning point for that density. And that, I mean, that I think could have even mentioned it more, but in some of their slides, they're showing how their plan is to get rid of all fossil fuels, whether that's fossil fuels in natural gas used for heating, for all sorts of transportation. That this, I think, and once again, I think to both of your points, I don't know if that's what Wall Street fully understood, but this, I think, was a very public way to show what the impact of this could be. This is Tesla was able to kind of put it out in front with their brand, but this is where the state of the art, but the realistic, is going for battery technology, and in a very short time. You know, I want to be respectful of everyone's time here. We're coming up on the hour, but I'm noticing a couple of questions that came through. One from Ed Jones, and he wanted to hear what are Sandy and Bob's thoughts on where charging rates will get to?
If we don't have gasoline to basically tax the daylights out of and make roads with, I'm thinking that our friends in government will figure out, hey, let's just whack the daylights out of anybody that has an electric charge. I'm not a big fan of government, but anyway, I think that's they're all sitting there rubbing their hands together, and that means your electric bill goes up everywhere. So I'm a big fan of getting rid of gasoline and in cars and whatnot. I think that's a good idea. But natural gas, I want to hang on to that. I don't want to have that go away. There's plenty of it. We can make our own if we want to from basically garbage dumps, but methane gas anyway. So I think that we're probably, it won't take too long before the government starts sticking their hands into our back pocket, our wallet or whatever, so that they can say, well, we got cars, we got to have roads, we got to do this, and on and on. So here you go, whack. So I think that that's going to be one of the things.
The actual price point of how this could impact the wider electrical per kilowatt hour is a good point. I should have clarified. He was asking about charging speeds. And I think personally, that's why I was so excited by what this battery had the potential for around kind of being able to minimize the challenges you usually have with the distances electrons have to travel by going from the tab to the tabless design. But yeah, if there's any thoughts that either of you have around the charging speeds, we'd definitely love to hear it.
Well, Chase, the technology already exists today for fast charging. The infrastructure is being put in. I go to Clare, Michigan to meet with one of my consultants up there, Advanced Battery Concepts, small battery companies working on bipolar lead acid of all things. Behind the hotel that I stay in are 9 high-speed charging stations for Tesla, of course. The point here is that the technology exists today for fast charging. It's a matter of what degree of charge you want into the car before you have to make your next mission in the vehicle. You can charge from a low state of charge up to 85% easily in a very short period of time. It's that last incremental amount of energy that you're trying to stuff into the battery pack that becomes the big part of the slowdown, if you will. So it's a matter of degree of how much charging you want to put into the car. In fact, there's getting to be enough charging portals around the country for high-speed charging that you could potentially cross the country in a very short period of time, regardless if you ever get your car up to 100% state of charge in the first place. So I understand the question. The technology already exists today to do what they're suggesting. 5 minutes is a little bit of a stretch, but 15 to 20 minutes is not a big deal.
Yeah, I can remember when I was young, a lot of folks, when we used to have a guy that would put the gas in your kink, they'd say, give me $2 worth because I only need to go to grandma's house. As we became a lot more affluent and gasoline prices didn't really go up that much, it was like fill her up was the standard. But I think that people have to get into the new mode where 80%, that's good enough for me. See ya, and then take off. I think that's what's going to happen. So I'm 100% in line with what Bob just said.
One of the things that struck me kind of interesting, Elon talking about the growth, and I just coming back from my tour of duty in China, you look at the number of factories that have been built in China to address the electric vehicle market there. Elon made a comment that they're looking at having approximately 100 gigawatt hours of production today in 2022, and by 2030 they want to have 3 terawatt hours of production. Stop and do the math. They mentioned that between now and the beginning of let's see, what was it? He said they needed 135 factories over the next 10 to 15 years to meet the production volumes just for Tesla's car business. That's a lot of factories, guys. Think about the industrialization. They have to build that many number of factories to build batteries. That is a huge undertaking. So the guys in the construction industry, they ought to be slobbering on themselves right now, getting ready for that ramp up, because that is a lot of revenue for those construction workers, construction companies, and the companies that are going to build the machines that go into those factories. That's huge.
Mm-hmm.
Hey, we've got a question here from Dave Tuttle. And Sandy, why don't we start with you on this one? He says, of the 5 major things that Elon talked about yesterday, cell design, factory, anode, cathode, vehicle integration, which ones do you think are low risk? Which ones do you think are high risk?
The anode and cathode is beyond me, so I'm going to give that to Bob. But for me, the big thing was vehicle integration. And the reason for that was when they talked about having the battery pack as one great big giant solid lump. That was something that was a recommendation I made when I saw the Model 3s over there. But anyway, when I saw the Model 3, why did they do that? I mean, the body resonates at the same hertz level as what the battery pack did. So why don't they just make it in one and call it a day? And last night, when he went through that and he showed the casting in the front and the casting in the back and how he's going to put the battery pack together, that battery pack now is, that is a structural member. So you got
But that's
three
nothing
great
new,
big giant
right?
castings.
I mean, I'm surprised Tesla's, it looks to me like they're the last ones to the party to make the back pack a structural member. I know, for example, the Jaguar I-Pace, the pack is a structural member, and that's been out a couple of years now. I know with the GM Ultium battery pack, that's going to be a structural member. I almost wonder if Tesla went down a blind alley by making the structural, the pack not structural, because at one point it had dreamed of doing battery swapping, and that becomes really difficult to do if it's a structural part of the chassis. So to me,
I think
the structural part of it wasn't news.
I don't think,
No, the
I think,
structural part.
I mean, I'd like to hear Sandy's kind of take on it, but from what I understand, technically, because I've known people who worked at Tesla and they've been talking about that in the S since 2012, 2013. You're right. It was designed to be removed in case there was maintenance needs or fast or battery replacement took off. But as far as I understand, the pack is a part of the structural part. The big difference is how the batteries are now directly the pack and in the actual undercarriage, essentially, versus having the separator. But I'd love to hear your thoughts on that, Sandy.
Well, yeah, that's precisely right. We're not looking at just what everybody else has done by making the outside shroud the structural member. He's made the batteries the structural member as well, and that's totally different. That's going to give him a Hertz rating that's going to be out of this world. That's going to be a very, very rigid body. I think that what I saw last night is something that nobody's ever tackled. To have all those batteries stuck inside the casting that he's starting around, or at least the shroud that's going around, and then gluing them all in. That epoxy glue and whatnot will be acting as a separator, but also as a tremendous rigid member. Nobody's got anything like that. I have every battery pack here, all of them. And at the end of the day, nobody's got anything like what they described. There's no little walls that separate them. This is like a gigantic pack that we're looking at, totally different than anything we've ever seen before from anybody. Nobody has anything quite like what I saw last night as far as the entire structure. But there were two other parts of that question, and I don't want to eat up all the time. So Bob, can you answer the anode cathode, at least that part?
Well, let me make, yes, I will answer those questions. Let me take a step back in time. There was a guy out in California, worked at AeroVironment, that created a little car for General Motors called the Impact. And that Impact became the precursor to the EV1. The EV1 had an integrated battery pack system that was a part of the chassis. I know, I helped design it. So this is not a new concept, to John's point, that the space available on a car is precious. The mass on the car is precious. We need to try to save on mass, and we need to save on space. So to do that, it makes common sense to create a structural space frame that allows you to integrate the battery directly into the chassis. This is something that's been done for decades. But to the point on the anode and cathode, some of the technology that Elon's talking about, silicon integration, everybody's working on that. It's just a matter of what degree you're doing it and how you do it. Most of the silicon integration today involves graphite. So the combination of graphite and silicon seems to be the mainstay today. Going to 100% silicon at this point is going to be challenging, even though it sounds like Elon's team is up to that challenge. But what they were talking about, the raw silicon being able to be stabilized, we're talking about some kind of coating or stabilization technology that already exists today. There's a few companies out there that already makes these kind of technologies. As far as the cathode side of it, going to a low cobalt technology, sure, everybody's working on low cobalt because of the cost and also because of concerns about its availability in the future when we start getting into the terawatt levels. But most everybody is already working on that, increasing nickel content to hold the structure together, as he was talking about. It's like a shelf. It's like a shelf technology in there. Yeah, you're stuffing lithium ions into these shelves, if you want to call them that. It's actually, I used to teach molecular orbital theory in college, and I don't want to get into that kind of technology, but it's a matter of bonding, molecular bonding, if you will, of the lithium in the interstitial spaces of the crystal lattice. But regardless of that, they're talking about being able to integrate these raw materials directly into the battery with very little processing. That's going to be a big challenge for him. I hope he's successful, because if he figures out how to crack that nut, he's going to be more wealthy than he is today. But it will also open up revolutionary technologies that many people have not made those major breakthroughs. One of the big challenges he's going to face is how long it takes to open a brand new mine, because just going through the federal government of most countries, it takes an act of God to get a new mine opened up, because of all the surveys they have to do, all the paperwork that has to go clear through both federal, state, local government agencies. It's a real pain to get new mines opened. And as far as lithium and taking lithium out of clay, this is a new one on me. I'd be very interested to hear how they're going to extricate the lithium conveniently out of that clay and return it back to its original soil and make it look just like it did before. So I'm quite interested in hearing about the technologies that he's got there. So I added on the lithium besides the anode cathode just for the fun of it.
The silicon, no, I agree. That's, I think, what surprised myself was the silicon announcement, just given, you're right, there's technologies that are kind of helping address some of the expansion issues out there already. But not only using silicon, but using pretty much what you get out of the earth. I think that's a great point. That's something I should have brought up sooner. That was something I think really did go under the radar, especially on the anode side. And then how far they went into the mining and what they're looking to do. I agree. I don't know if it's going to look the same, but I think the theory is the dirt will be in the same place more or less. So we'll see what happens there.
Yeah. Chase, it's kind of funny. Just a couple of years ago, they found some of the old nickel iron batteries that Thomas Edison made back at the turn of the century in the 1900s. They rejuvenated those batteries. They still work.
I mean,
are we going to face
I
the
think
same thing with the lithium technology in the future? So I like to go back and look at what people did in history years and years ago, like Dr. J.J. Lander making the first maintenance-free lead acid battery. That had to be a major undertaking to do that, but it revolutionized the starting battery in the lead acid industry years ago. So I think what we're looking at right now is Elon is forcing everybody else's hand to accelerate their development. So I think you're going to see a surge, if you will, toward the electrification effort, because every major car company in the world has already made their public announcements about what kind of product portfolio they're going to launch in the years to come. All Elon is doing is pushing the acceleration. So sometimes when you push on the accelerator, sometimes unexpected things happen.
Yeah, and that's a good way of saying it. I mean, a race car sitting all by itself with the engine running doesn't do a thing. You put a driver in and he steps on the gas, the accelerator, and away you go. And that's what I think really and truly we should thank Elon Musk for. He is pushing an accelerator. I mean, really and truly, ask anybody on the planet, or at least in North America, who Elon Musk is, and you'll get all kinds of things happening. People know who he is. Ask who's in charge of Chrysler, or ask who's in charge of Ford, or ask who's in charge of BMW. Nobody will have a clue, because they just aren't doing the same kind of a job as what Elon Musk is doing. I mean, I really didn't care for the guy before, but it's hard not to like somebody who's basically turning the whole industry on its head. By the way, there was one other thing too. We were talking about the manufacture of the products. The one thing that he showed was, if he can do this dry processing that he was talking about, did you see how much smaller the plant was? I mean, really, that's like down to about 1/10 So if I make a big giant factory and I use this new techniques and technologies, I should be able to get a whole bunch of product out of the same footprint that I'd have in the old factory. And quite frankly, we've done that. I mean, again, you've already commented on this or had it on your show, John, but when we did the club car, I mean, we took 2/3 of the factory and abandoned it to make a product in a footprint that was like 1/3, and it did 3 times the amount of put out 3 times the amount of vehicles, and made them a tremendous amount of money. That kind of stuff is what happens when you've got breakthrough technology coming in, because really, if you do things in the same old way, you're always going to get what you always got. But if you change the rules and you change the way things are being done, good things happen. So,
Chase, maybe you ought to take a couple more questions.
Yeah, I just want Bob, Sandy, do you have the time to keep going a little bit longer?
I don't
Sure.
know.
As long as I can
okay.
as long as I can keep the dogs from barking, we'll be okay.
Yeah. I got how much time?
Let's just do a couple
Up
more
to me.
questions,
Oh,
and
okay,
then we
well,
can wrap
it's
up.
up to me. I don't, I'm good. Whatever you want to do is fine. Go ahead.
Go
Okay,
ahead,
great.
Chase.
I mean, we've actually had a bunch of questions submitted since this started. There's a few questions around, let's see. And I think this is a little bit going off of what we just discussed, but isn't part of the reason for Elon's presentation to stimulate competitive responses and help build the supplier base, divert investment to EVs from internal combustion engine powertrains? I think the answer to what we just discussed is a pretty resounding yes.
Yeah.
Well, that's
Yes.
one of the, and Chase, this is the person's asking the question has got a great point. You're talking about growing the business to 3 terawatt hours by the year 2030. Think about the supply base. It's currently supplying, 100 to 200, 300 gigawatt or megawatt hours today. You're going to have a multiplier beyond belief for all these supply bases to develop the technology to make the products in that kind of volumes. It's huge. So the supply base is going to be a network that's well beyond anything we see today, plus the shipping and transportation of those raw materials. It's going to be a big deal.
One of the other questions, and they didn't really come out and talk about this, but one of the questions is this the million-mile battery?
Well,
No.
Who needs the million-mile battery? This is not, no, this one isn't, but the only thing that you need a million-mile battery for is like giant trucks. Nobody else is going to survive 1,000,000 miles. I mean, talk to a lot of people, and you very, very seldom find somebody that's got 200,000 miles on their car. What do I need 1,000,000 for? Only big tricks, like Class 8 trucks and things like that. They want to see that kind of use, but the ordinary car, it just isn't going to happen. So what if I got 1,000,000? That goes back to John's question. Why am I paying for a 1,000,000-mile battery when I'm never going to use it?
The technology already exists today to have a 1,000,000-mile battery, Chase. It's just
Right.
a matter of depth of discharge that you take
Right.
the
Yeah.
battery down to. If I take a battery pack and I only cycle to 20% depth of discharge, recharge it.
Yeah,
I
forever.
mean, we had, this is funny, the Department of Defense, we were doing some work with lead acid batteries back years ago. We set a lead acid battery at 78% state of charge, and we cycled it millions of cycles, plus or minus 3 to 5%. The battery never deteriorated because we hit the sweet spot in the what they call the 100% efficiency realm of the battery. It didn't change. It's like it was sitting on a shelf, except it was being cycled for millions of cycles. So almost any battery technology that is reversible cells have that capability of doing that. It's just a matter of degree.
Yeah, actually, if you look at World War II, the submarines there, all of them were lead acid batteries, and they had way more than 1,000,000 miles on them. That's for sure. I mean, they were running all the time. We just kind of forget. Everybody gets kind of like pigeonholed and says, "Oh, this is what we're doing right now." But if you expand it to what happened in history, suddenly you've got tremendous amounts of examples that show you that almost anything is possible.
So, yeah, and I think one question, I don't think this was addressed yesterday, but is Tesla changing the amount of nickel according to the use case, but keeping the form factor of the new larger battery, or will Tesla continue to use the current batteries in cars?
Well, you have to go up
They
in
have
nickel
to.
content because they're going up in capacity.
Right.
Capacity, the amount of storage capacity is directly related to active materials that go into the battery. And Elon even mentioned that the car is going to have a lot longer capacity, meaning longer range, excuse me. So longer range meaning more capacity. More capacity means more active material.
I think the question is
they're gonna
around
have
if they'll keep the form factor and experiment with the chemistry, but
I think what they're going to have to do is they're going to have to keep these for a long time, because these ones are not going to be produced next week.
Right.
So, I mean, it's going to take a while to get to this. So they're going to get stuck with this. So this is going to keep on going for quite some time, I think.
you know what's also standing out is we are getting a lot of Nikola motor questions related. So I think to sum up, what if either of you could just give a quick take if you see any opportunity for hydrogen, or was this announcement kind of confirming that lithium ion will be the most likely choice for electric vehicles moving forward?
Hydrogen, yes, it's going to be the fuel of the future, and it always will be.
You can't have a hydrogen-based car without a battery system in it. You can't ramp.
Too.
You cannot ramp up and ramp down fuel cells fast enough. So there will always be a battery pack, even with a hydrogen fuel cell vehicle.
Right. The only guy that had it nailed was Toyota, but they couldn't make that that they had a very beautiful weave mesh that was inside the cells that got them from when we were working with Ballard, the best we could do was 0.8 volts per cell, and they got it to 1.3. That's amazing, but it couldn't be manufactured. It was more like a productionized prototype. So I'm gonna say that probably not in my lifetime will a fuel cell take over for battery packs or even ICE. So it's gonna be a no.
Yeah, I completely agree. I think fuel cells have some very unique applications, but that is not in replacing the general automotive space.
Well, I would say watch out what you're saying there, because China, Japan, and South Korea are really pushing hydrogen and fuel cell vehicles.
Right.
And when you see that amount of government R&D work, that amount of government subsidization, yeah, it's early in the fuel cell game, but with 3 countries like that really backing it, I think the fuel cell is going to continue to develop.
I think it'll continue to develop, but I think the big theme we're seeing from yesterday and even conversations today is that acceleration. And
it is, but you know,
yeah.
I'll speak as somebody who lives in the snow belt. Electric cars don't do all that well in cold weather. They can lose half their range. And yeah, okay, so the range is getting bigger and bigger, but now I've got to go out and buy more battery to compensate for up to a 40 or even 50% degradation in range just based on temperature. I think there's going to be certain duty cycles where fuel cells are going to be rather attractive compared to a pure battery electric vehicle.
I think there could be a lot. Oh, you go,
Sandy. The thing that's
Sandy.
missed is, I mean, making hydrogen. It's not the easiest process on the planet. And as I mentioned on one of John's shows, actually, I said that I was in China and some Australian guy showed us a brick, looked like a house brick to me, and he said it's full of hydrogen. And I said, really? I mean, how did you get it there? Well, that's a secret. So they figured out. This one company had figured out how to make hydrogen much cheaper, and then they figured out how to take it and stick it inside of his brick, which makes it easy to transport from one place to the next. The infrastructure for hydrogen is going to probably be a little more exciting than it is to put up a charging cell. And I know that, yes, Japan has taken, that's why they're a little bit behind the curve, but they've gone in that direction. And Korea's trying to follow. China, I think for China, I think you're going to see lots and lots of work on electric vehicles, because there's where the most batteries are manufactured. Okay, so Tesla's got, this new battery here, but there's plenty of battery capacity in China for making all kinds of cars, and Chairman Xi, that's his focus. He's got a focus on battery EV vehicles, electric vehicles. So I don't know. I think that it'd be great if somebody could do it. I don't know how they're going to have an infrastructure that's going to be put in place while we're changing from gasoline to, unless you go with there's another thing called HBT, hydrogen burn technology, that you could take natural gas, or you could take in some cases some refined gasoline, and you can turn it into hydrogen, and then you can run but you get this bottle of sludge that you don't know what to do with. There's lots of things that would have to be solved. Whereas this, I mean, like, I'm really excited about this being ready pretty much right now. And this one is right now. So
we're seeing a lot of investment globally, especially, like you said, with certain governments around hydrogen. I'm not against it by any means if something changes, but this isn't the first time. California, obviously not the same scale, but a large state with a lot of money, did a lot of investment in hydrogen in the early 2000s. Try and drive a hydrogen car around most of California, you're going to have an issue. Like, it just is. There's a lot of scaling issues that you just come into. But I think that could be its own episode. So before we go down that path too much further, let's see, because we're coming up. Yeah, we just passed 9:30.
If you have one more burning issue, Chase, let's get to it. And if not, look, we ought to start wrapping up.
Yeah. Okay. So we've got, and I think maybe we'll try and answer some of these over the rest of the week, because there are some great questions here. But another kind of current trend I'm seeing is only VW is taking Tesla seriously. Why are others not?
Go ahead, Bob. I get a lot of hate mail, so why don't you take a shot at some of this stuff?
Well, I think maybe Volkswagen is viewing Tesla as a legitimate competitor, and maybe others, maybe not as much. I think part of it is that Tesla has taken a different business model than most of the car manufacturers, and perhaps they're not considering the threat, or they're envious of how they do it and get by with it, because I think Tesla's done a marvelous job of helping accelerate the electrification efforts in the world, and on all fronts. As Elon maybe alluded to yesterday, Tesla's the only automotive manufacturer from offshore in China that owns 100% of its shares in that country. But I also want to make one other comment before we get off the air, Chase, because I made this comment a little earlier and don't want to let it get by. The Battery Day announced new technologies that Tesla is working on. There are a flurry of other companies. The plethora of companies working on new technologies is massive. Just because they announce certain new technologies doesn't mean that everybody else is stagnant in the industry. There are a lot of alternative technologies that will compete with what Elon was talking about yesterday, and that may be better than what he's talking about in a very short time period. So let's not all get all excited and enamored about what Tesla's Battery Day announcements were, because there's a lot of other companies out there that are working on new technology that will compete with those technologies head to head within the next few years.
Yeah, I would add something too to the question that how come it's only Volkswagen that takes them seriously. I can tell you for a fact, every major automaker in the world now takes Tesla seriously. They don't talk about it publicly, But I tell you privately, and I know because I've had these private conversations with very senior leadership at different car companies, they absolutely take Tesla seriously. Herbert Diess, who is the CEO of Volkswagen, the Volkswagen Group, is the only one who has gone out publicly and said nice things about Tesla. In fact, Elon Musk recently paid a visit. Apparently, they're pals. They drove around in an ID4. Elon, sort of backslapped it with compliments that weren't all that great of a compliment. But Herbert Diess is the only guy, the only CEO of any major corporation, car company, that's come out and praised Tesla. But I can tell you, the rest of them absolutely take it seriously.
Well, I can tell you one thing for sure. We have a couple of little vehicles here that we're helping develop, and we may be getting another one actually from a guy named Malcolm Bricklin. Maybe you remember him. But two of those little companies, Malcolm's company and Nobay, the cute little car that we're working on, both of them want to use Tesla products. We want to implement Tesla's drivetrains, Tesla's inverter converters and whatnot, because we know no one else will work with us. Nobody's really got enough on the market. And I don't want to try and produce a vehicle that's sourcing from who knows where. So I want to have something that's going to be built in America and things like that. So with the Nobay and perhaps the advent of the products that are coming out of Bricklin that Malcolm wants to make, I want to use something that's got millions and millions of miles on them, like Tesla's got already. They've already proven that their electric motors and their AC systems and everything else seem to work really, really well. I want to have batteries that look like this, because I'm going to try and get in touch with Tesla. Actually, right after we're done here, I'm going to be phoning California to see if I can talk them into helping us out with components or investing or what have you, because these things, I think these little cars are what they don't build, and we need to have, because the urban areas have been pretty much neglected. The New York cities and the Los Angeleses and whatnot. I think that there's a market there that's huge, and anybody that's gone down the Ventura Slowway, because you can't call it a highway, it's definitely slow to go down that. If we could put in, say, an extra 2 lanes for cars that are a little bit smaller than what we drive around, using Tesla's technology, I'll take that all day long. Regardless of what I said in the past about anything, I think that now they're the guys to beat. Everybody else has got a problem, not them. So, and I'm not 100% sure, but I think I'm getting waved off, so I may have to take off. But you guys could. I don't want to be the Debbie Downer and screw everything
No,
up.
I appreciate that, Sandy. I think we've kind of gone over what we had planned for anyway. But just to wrap up, I want to say thank you so much, Sandy and Bob. This has been, I've found it very interesting. Would love to continue these conversations on another time and offline as well. Thanks again, John, for this opportunity to kind of host this today. And I will look forward definitely to talking more soon.
Yeah, thanks, Sandy, Bob. Really enjoyed talking with you guys. And Chase, great for running the whole show here. Good job.
Thank you.
Well, thank you. Thank you for inviting me. It's a great honor. Thank you.
Thank you for the opportunity. We appreciate it.
Well, I know it's our pleasure, and we'll talk soon. Thank you.
All righty.
Thanks.
Bye-bye.
Thank you.